So Unit 10 is going to be one of our last units that we really have any kind of review. Pretty much from here on out, it's all going to be new stuff. But in this unit, we're going to review a little bit more about concentration so we can really take a look at different types of solutions. So if you remember, we talked about molarity, mass percent, mole fraction, and molality. And I know when we went over them last year, when we went over them at the beginning of this year, these can sometimes be some tricky problems. So I've got a couple of examples in here. But I also encourage you during this video to grab a calculator and perhaps your textbook because I'm going to work a couple of the examples that the textbook has. Okay. All right. So composition, obviously concentration means a lot when it comes to trying to figure out what's going on with a solution. And there are 4 types of very common ways of figuring out what a concentration is. And I've got them all listed here. And unfortunately, I think AP only gives you molarity, which probably means you should probably just get to know these pretty well. And the only time that they're really tricky is the molality versus molarity. Molarity has liters of solution, whereas molality has kilograms of solvent as opposed to solution. Now, over here on this side, if you notice, I abbreviated solution as SOLN. But the thing that you see in common with all of these is whatever is on the top here has to do with the solute. In other words, what are we putting into the solvent to be dissolved? And together it makes the solution. And I highly encourage this strategy to make sure that you can kind of separate the different pieces of the solution. So for the first practice problem, I have a solution of 1 gram of ethanol, and it's mixed with 100 grams of water to give a final volume of 101 milliliters. So over here, I'm going to just put, I have 1 gram of my ethanol, and I'm just going to put E to make it simple right here, and 100 grams of water, okay? And the only thing we know about the solution right now is it totals up to 101 milliliters. Calculate the molarity, mass percent, mole fraction, and molality of ethanol in this solution. So ethanol is definitely our solute. It's the lesser of the two, and it's being dissolved by the water. So my water is my solvent, and together they make the solution. So first off, we have molarity. And to get our molarity, we first need our moles of solute. So our solute is the ethanol, and it has a molar mass of 46.08. And if we have 1 gram of it, then we have 0.0217 moles of it. Okay, so I'm going to put that on top. And I'm going to divide this by liters of solution. So this is, we have 101 milliliters, but you have to make sure and put that in liters. And so when we divide that out, we're going to divide it by 0.101 liters. And I'm going to get a molality of 0.214. Actually, that will round to 5. And that's a big M for molarity. Okay. All right. Mass percentage. All right. So we need the mass of the solution, which we were already given. So we have 1 gram over the total mass of the solution, which means I have 1 gram plus 100 grams. And in this case, it's pretty easy. I got 101 grams on the bottom. So I've got a mass percentage of 1 divided by 101. And I have to multiply this by 100. I know I didn't write that there, but times 100, slap a percent sign on it, and we're going to have 0.990%. There we go. All right, mole fraction. We need the moles of the solute, which we already figured out down here. So I'm going to put the moles there, divided by the moles of the solution, which means I need the moles of the solute, okay, plus the moles of the water. So down here, we know that water has a molar mass of 18.02. And if we have 100 grams of it, then we have 5.55 moles of it. So I'm going to put that there. So we have to add those two together on the bottom. So I'm going to take 0.0217 divided by 0.0217 plus 5.55. We do not multiply this one by 100. This stays as a decimal point without units, and this is 0.00389 for our mole fraction. All right, last one up. Molality is moles of solute, and again, this is different than molarity. Up here, that we are dividing by liters of solution. Down here, it's kilograms of solvent. So we have our moles of the solute that we've already figured out, so that's going to stay on top. Okay, and we're going to divide that by the kilograms of the solvent. So this isn't the solution, it's just the water. And if it's in kilograms, then we're going to divide this by 0.100 kilograms and switch that out. There we go. And then that's going to give us a molality of 0.217, and that's going to be little m. Okay, I hope that helps. Again, if you're not getting the same answers that I'm getting right here, I suggest that you look up the first example problem in the textbook and check it out. Now, I know you're all familiar with these since we've talked about them before, but there are other ways of doing concentration. So there's one more we need to talk about. It's called normality, and there's it's actually used a fair amount, but it's normally very specific to acids and bases, and it's also specific to redox reactions. So we're going to have to do a little bit of review on redox. Normality depends on what's called an equivalent. And for example, if I have an acid, I'm looking specifically at how many hydrogens it has because that's what makes acid an acid. So for example, my sulfuric acid here, H2SO4, has 2 equivalents of hydrogens. The calcium hydroxide, which is a strong base because it has our hydroxide component there, it has 2 hydroxides, therefore 2 equivalents for a base. So 1 equivalent of hydrogen reacts with 1 equivalent of hydroxide. And what I mean by that is H plus OH gives us water. All right, so we have to pay attention to equivalents because H2SO4, my sulfuric acid, is actually twice as strong as, say, HCl. HCl only has 1 equivalent of hydrogen. So here's what I'm getting at. If I have HCl and I have H2SO4, okay, I'm going to need less of the H2SO4 to neutralize 1 equivalent of base. I would only need a 1-to-1. It's basically stoichiometry. For HCl, I would only need 1 equivalent of HCl to go with 1 equivalent of base. Now, where this gets a little bit trickier is when we're talking about redox. You have to figure out how many electrons are being transferred to figure out the equivalence for normality. So, for instance, I have permanganate, MnO4 minus, plus 5 electrons plus 8 hydrogen is going to give me Mn2 plus and 4 waters. So in MnO4 over here, if you look at that, you can tell that I have an oxidation state. If you look at it, I've got right here with my oxygens, I have -8 because there's -2 each. So each oxygen is -2. I have a negative sign on this, which means manganese right here has an oxidation state of +7. Okay, over here it has an oxidation state of +2, which means 5 electrons are transferred. So that also means there's an equivalent of 5 for permanganate. If I wanted to figure out the equivalence of mass, in other words, what mass of this stuff do I need for 1 equivalent of oxidation, I would take the molar mass of whatever this system is, like the permanganate. I would take the molar mass of it, divide it by 5, because that's how many equivalents are in it, and what this is telling me is I need 31.6 grams of this stuff for 1 mole of equivalence in redox. So let's look at a practice problem. And in this case, I'm going to look at the normality of an acid. Okay? For normality, and this isn't probably as difficult as you might think, you're going to take molarity times equivalence. So you just got to figure out whatever the equivalence number is, whether it's redox, an acid, or a base, and find your molarity and multiply it by that. So this practice problem asks for mass percent, molality, and normality. I've already gone through a mass percent and molality example, so I'm not going to do that. But I am going to take a look at the normality piece of this. So in this case, it's telling me the electrolyte in the automobile lead storage battery is 3.75 molar. Okay, and it says that it's a sulfuric acid solution. So that tells me right there that sulfuric acid is H2SO4. We just talked about it in the last slide. So H2SO4 has 2 equivalents of acid. So I'm going to multiply my molarity by 2, and I'm going to get 7.5 normal solution. That's how you would say that. I have a 7.5 normal solution of sulfuric acid. Now, I encourage you to try the other pieces to this practice problem. You should get 29.9% and 4.35 molal. If you don't, or if you need some more assistance with this, I suggest that you look on page 501 on the textbook and ask me if you have any questions. Okay? I hope this was helpful, and I will see you in class.